Thank you, Max, for a kind introduction. So I'm going to be talking about memory issues in Elixir. I first was introduced to the system through programming Erlang. I used to work in a company called Ring Central. They're the cloud telecom company. Then I switched to Elixir, and to be honest, enjoy it much more now. And I work for Choosy. So basically what Choosy does in short, it's a food planning, meal planning companion app that allows you to plan your meals for the week for you and whole family. And it's mainly focuses on enabling you to achieve your goals like healthy eating, reducing waste if you want to, or keeping within a budget. So the reason Choosy actually chosen Elixir is because the technology proved for them to be very cost-effective and be able to keep a lot of simultaneous connections, handle a lot of simultaneous messages. Like, for instance, even on production, now we are running only 2 nodes. We could do with 1, but we keep second for redundancy. And each node have only like 8 GB of memory. So actually, on a daily basis, we don't have any problems with the memory. But we did have some, and they were not really expected, and hence they were not very easy to debug, because back then none of us in the company really understood how the memory model works in Beam. And it's not quite in another languages, even other garbage collected languages. What do I want to say is, as Elixir as a functional language and is garbage collected, you don't really have problems with the memory usually, but then they arise, they're hard to debug. But first of all, who knows anything about like memory allocations, know something, deallocation, so maybe work with different languages. Who knows what a garbage collector is? Oh, okay. That's much more than like just a memory allocation. Who knows how garbage collector works in a Beam specifically? No? Okay, that's some people. Okay, let's quickly try to get everyone on board. So this is a simplified version on how Elixir process memory looks like. So there is a heap and stack. We won't be focusing on stack. Usually there isn't much going on. Most of memory are allocated on heap, and this is heap. This is a heap that's unique and owned for each process of Elixir, of Beam. So then allocation happens, some memory is taken from heap, it grows towards the stack, then memory is reclaimed, the heap grows back. At some point, stack and the heap gonna meet, that's a natural thing, and memory can no longer be allocated. Then garbage collector is called. Simply saying, Elixir uses the Beam's tracing garbage collector, so it just checks what objects can still be reachable, what data can be reachable. We don't really have objects. The ones that it cannot reach are reclaimed, so they are removed. So the basic things about Elixir memory management come from the Beam pillars of memory management. So the first thing you probably all know, memory is not shared between Elixir processes, and all values are immutable, as this is a functional language, and so hence if you do some modifications, you just create a new value. It is optimized somewhat, but in general, this is how it works. The interesting thing, I didn't really think much before, that all the memory for the process is owned by it, including everything that stays in ETS table, because they have owner. Then process terminated, ETS table is removed as well. But ETS table, when it's still alive, it manages its memory by itself, so it won't involve any garbage collection or whatever. It's implemented with nifs, I think, like in a native code, the ETS table. Yeah, but it itself belongs to some process anyway. So if the data is not shared between processes, then you send anything to a process, it have to be copied naturally. So the data is copied, then it's sent between processes. Then it's given as an initial arguments to the process on a startup, and then it's written to read from ETS. Now, everything pretty logical here. Yeah, there is exception with the literals and so-called big strings. For my talk, it won't matter much, so we won't be covering that, but I do advise you to read about like off-heap allocation and big string and how like the reference counting works in Beam. A pretty interesting topic. So now let's look into example. So it's taken from what we have in Choosy. For your meal plans, you're gonna have a recipe as a basic building block, and you have a product. The product is something an abstract you can cook from, like tomatoes or pasta. They're not much. These are not exact numbers, like there is like 1,000 recipes in the database and 100 products. Not exact numbers, but actually very close to what we have in the system at the moment. The thing about product, it's a pretty big data structure, so it's going to take relatively more memory. Because it has like nutrition information, packaging information, unit conversion, a lot of technical stuff. So you associate recipes with the products through recipe ingredients table. That is just many-to-many SQL association, but it also adds the information about amount and unit. So recipe ingredient itself is like 2 tomatoes or 300 grams of pasta, already not so abstract. Right, and because each recipe have from 5 to 20 ingredients, you're gonna have about what, like 12,000 recipe ingredients in the database, but it's a very small structure. So hopefully you can see it, but if you don't, it doesn't matter much. It just shows that we're using the Ecto recipe has many ingredients of the recipe ingredient type, and recipe ingredients belong to the products. So we use these associations to preload all the data. So here we load all the recipes, and for each recipe we preload all ingredients, and for each ingredient we preload product. We load all the recipes here because we actually need this. This is how it works in the product. We're gonna send it to AI-like tool to try to generate the best fitting recipe for the household for the week, and it needs to see like the all possible solution playing to work effectively. Very simple code that doesn't even return any result. Let's see how it performs. I'm using an observer, and I've been running it several times, of course, but just one run on the graph. It consumes 20 megabytes in memory in heap. So very simple, you load data on your process heap, then you dispose of it after request is gone. But it is pretty wasteful to load all the recipes all the time. They don't change as often. So we're going to introduce cache. Just one line, it uses Nebulex cache with a local backend, so effectively it's going to store cache data in ETS table. I believe it uses ETS table with like compression flag on, but it won't matter as much. And I checked the behavior. If you would try to store your cache in a separate running process, it's going to be the same. So I'm telling you that because I'm going to ask you a question. There's going to be a trick there. But nevertheless, try to answer it, really appreciate it. So how the memory consumption performance is going to change after we added just a simple cache?
Should decrease.
Yeah, of course. But how much? I mean, you're going to copy memory, obviously, what we've seen. That's a very logical assumption, roughly double. I mean, it makes sense. You're just going to copy it also to the cache. That's assumption we always had. Oh, this is a little bit more complicated, but to see. But on left, you have one request. This is what we already seen. The red line, I enable the cache. The first request I do still takes 20 megabytes in heap, but it takes 55 megabytes in the ETS. Okay, we might ignore that and think Nebulex cache maybe does some fancy thing with caching. We don't really know. But what's interesting, the second request, after we already have cache, gonna consume 100 megabytes on heap above what we already cached in the ETS. Why so? Does anyone have an idea? Maybe already someone know?
Because it has to pull data from ETS to work with it.
Yes, but why it takes then 100? It used to take 20.
Copy of data.
Hmm?
The copy of data.
Yes, it's gonna be copied, so that's correct. But there is something in this copying that actually makes it like return you bigger, because supposedly it should be the same 20. You didn't really change anything, right?
Keeps it in the process heap, and then ETS have its own part of memory.
Yeah, okay. We go to the topic of loss of sharing. So, a quick recap. Memory is not shared between processes and ETS. So you need to copy your data. That's what we've seen. That's what we expect. But copying data involves so-called loss of sharing. So the terms that been shared, the subterms that been shared in your data, gonna be flattened. They no longer be shared. So returning to our example, remember we had recipes, recipe ingredients, and products. We only have 100 products, and we preload them with Ecto. So it preloads only this 100 data entries, 100 memory entries, and it's going to share it between 12,000 of recipe ingredients. And some might say, like, I already told the memory is not shared. Yes, it's not shared between processes, but it's very actively shared within your process. Because it's like, doesn't matter for the functional language. Every time you modify something, it's gonna just create like a full copy, a copy of your data and modify it. And so what happens is that then you copy data to the ETS, your 100 products gonna become like 12,000 product entries because they just copied, so the sharing is not preserved. This is the optimization. Erlang documentation actually claims that its optimization is because Beam does not expect you to send like data with the shared subterms between processes or to the ETS, and so they just don't try to preserve sharing. They just copy whatever they see right away. So you can use ERTS debugs .size and ERTS debug.flat size to see like a difference from what your date term is actually occupying the memory and what it's going to occupy if it would be flattened. This optimization could be turned off with a flag, but I think up to now it's experimental and it's a compile flag, time flag. So you need to recompile your Erlang package that includes Beam for that. Yeah, so that's pretty much the answer to that. So no questions? Okay, we're going to the next topic. I hope you enjoyed the talk so far, because now it's going to be going downhill from here. Yeah, sadly, I could not find a really good standing out example for the next topic. But basically, it's all going to be about the memory leaks and alike. So what do you think? Can Elixir really leak? Oh, someone said sure. The boring answer would be no, it's garbage collected, blah, blah, blah. Reality, it can leak as all other garbage collected languages, then you just forget to remove your data. Like, think you have a long-running process where you store and state the map of user session ID to some data. The user session is gone. you forgot to remove this user session data by ID, and there won't be any way for the platform to know that you're not going to be using this data anymore. So it's never going to be garbage collected. So yeah, it mainly happens in like long-running processes in their states or in ETS. You also put something in ETS, forget to remove that. It also can happen through nifs, but as this is a native code, gonna depend on what language you use for native code, so it's impossible to cover in this talk, of course. A more interesting topic is sometimes then you look at your graphs, it looks like your application is leaking. Well, actually not. Like I had few occasions that I would see the memory increasing and staying for an hours of our cluster, then the pressure of requests already fell down. And then at some point after hours and hours, the memory will start being reclaimed. It's pretty bizarre because it's garbage collected language, I cannot reclaim my memory right away. But this can happen. Long story short, the heap isn't just that simple as we've seen, because Beam has a generational tracing garbage collector, to be more precise. So it's actually going to have an old and young heap, or young and old heap. And what's going to happen then you create some objects, then you need to allocate memory. They're going to reside in the young heap. Every time garbage collector runs, it not only deletes the memory that's no longer used, the entries that are no longer used, it remembers if it's already seen this entry, this object through the previous run. And if it was not reclaimed, if it was not collected 2 times in a row, I think it's going to move it to the old heap. The catch here, then garbage collector gonna run, it's always going to run on the young heap, but it's not always going to run on the old heap. So it's not always going to reclaim your memory in the old heap right away. There is no way for you to control that. This is just how it's implemented in Beam. You can use erlang.garbagecollect to force it to run on both heaps, but I would not recommend it because it can effectively reduce like a total effectiveness of your system, because then you run garbage collector, you effectively block your process. It cannot like do anything. It's frozen for the garbage collect. It's not as bad as like Java, then garbage collection can freeze all your application, but still, if you're gonna do it a lot, probably not a very good idea for production code. So the one example that I had of how it could happen, returning to that example with like a process that stores a user session info on its state. So it's going to store this user session info in a heap, and supposedly it modifies it pretty frequently. But not all users are active all the time. So some users are active, and then their data is modified, is going to be collected. But you can see how for most of the user, garbage collector will see that their data is not collected. So it's more persistent. It's going to move it to the old heap. Then this user become active. And basically, like, you modify data for them, you throw away the old data, but it's already in the old heap, so it's going to like pile up there for a while. In that case, I would recommend try to look if you can store this data in the ATS. Simple reason, it manages its memory by hand, so it never deal with any garbage collector. Then it needs to free memory, just freeze it in the native code. Another much more interesting example. So you know, like, the process have their message box, but did you ever wonder where these messages actually reside? So for the most part, most cases, this is like a default behavior. Then you send message to the process. The Beam have to allocate some memory for this message, and it's going to do it in the destination process heap. And so if your process happen to pile up messages, then it processes some. If you're going to trigger garbage collector, it can likely also see that those messages that's still waiting to be processed, they're not reclaimed, they're like persistent. And so it's going to move them to the old heap as well. But the nature of the message, you process them and you throw them away. So that's also can be a reason why you like seemingly accumulate some trash that is not collected. The best approach here is just sadly try to design your processes the way that they won't accumulate a lot of messages. That's not a good sign. Try to distribute them better, or not block your process on processing some message. If that's still not an option, you can look into the flag that can tell Beam to allocate the memory for the message of heap, of the process heap. There is like a VM flag and also flag that is like a process flag, so you can set it up per process. But documentation, Erlang documentation say it's less effective to store process messages like in the off-heap memory, so maybe not also the great idea. So the tools. Observer, a great tool. To be honest, I don't think I ever needed anything else to debug like memory in Elixir or Erlang, or like to also check if some processes are piling up the messages in the mailbox. Really useful, but you need to be able to connect it to your cluster. We use Docker containers on AWS ECS. I didn't figure it out yet how to connect Observer to our cluster. So, and I don't need to, because there is Observer CLI. You can add it as dependency to your process, and all you need is just an IX shell to your cluster, and you can start Observer as a CLI tool from there. You can order through the memory consumed by your process or by the amount of messages in the mailbox, and see what is like a culprit for your high memory consumption. Okay, that's I think more or less all I had. So any questions?
Thank you for the presentation. Very interesting. Quite some time ago, I've got issue that Phoenix channels send messages to clients through Cowboy, and that Cowboy process kept a lot of allocated memory because it was like several thousand records were sent through channel, and this memory had never been deallocated after that. I believe it was because of many binaries, so it was a binary heap, which works a little bit different, as I understand. Do you know, does anything change since then, or did anything change since then?
Oh, I think probably not. Yeah, the thing with the binaries, we briefly, I just told it like it works differently. Yeah, but the thing is with them, if you have a big string, like a binary 64 bytes plus, it's going to be allocated off heap, and the processes will only, keep a reference, and they're going to be like reference counted. So I don't know. Yeah, that's the problem with the reference counting. It still belongs to the process, but it belongs in a shared way. It can belong to many processes, so maybe it was still like referenced by other process. I don't know.
If you send a request to garbage collect, exactly Cowboy process, not your channel process, but Cowboy process, then memory was deallocated.
Oh, okay. Yeah, I can see how it can happen. So yeah, it's like the problem with it is mainly because you're gonna have just a very small reference in your process memory, but it's gonna point to like a bigger allocation of heap. Of heap itself, I think, is not garbage collected; it's reference counted. So yeah, unless maybe your problem was that it actually somehow ended in the old heap. That's why it was not like garbage collected naturally. It's like The garbage collector runs on the old heap according to some heuristics, but it might example depends on your application if these heuristics will work. It mainly looks, I think, in the size of your young heap and the old heap, and it's not always trigger it. Yeah. So I can nothing changed. I cannot really like recommend anything.
For the binary sharing, those binaries are still only shared though within the same process. It's not being shared.
No, they're shared within processes. That's I think, yeah.
Across?
Across, yeah. But they are binaries. It's like if you're gonna modify them, you still need to create like a copy of it, right?
Sure. So how does the beam transfer the reference to a binary from, like if you send a binary from one process to another?
It just sends the reference, so it does not copy your binary.
Oh, okay.
Yeah. It's like optimization, I think. Yeah, I do really motivate you to read like about this specific case is described in the Erlang documentation about like the big strings, the binaries, and generally also can touch upon like the off-heap memory that Beam has, and interesting stuff. Yeah. Kind of like not. Things are not shared between processes unless they are.
Unless they are.
Unless they are.
Thank you.
Do you have another one?
Yeah,
Go
sure.
ahead.
So in your first example where you put the cache into ETS, if instead you had, and I know there's a concurrency issue here, but if instead you stored the result in the state of a gen server, you'd have all those links. It wouldn't flatten things, right?
It would not be different because the request itself is like a short-living process, so you need to have another process that can hold your cache. That's going to be like a long running, and then you send your cache data to that. It basically works as a message. It's going to be fully copied or like deep copied, like some other languages call it. And it's going to be flattened the same way, so it's going to be like basically the same behavior.
Okay, but if the gen server itself did the query and then stored it as its state, you wouldn't have any of the copying, right?
You will have copying only then you request the data from this process. Yeah. But if you store it right away, yeah, no problem.
Right. So you won't have the growth, but then you have concurrency issues with how many messages how many consumers can access the gen server simultaneously. Because with ETS, you can have multiple processes pulling the same.
Yeah,
so if you have the concurrency trade-off is okay, then you can store the query results directly in the gen server that makes the query, and then you don't have the extra overhead, memory overhead, right?
Yeah, that's correct. What we did is we basically ended up like storing the recipes and the products separately and just joining them, like requesting them separately from cache and joining them.
Putting them
like,
in different caches.
Yeah.
Okay.
That worked. Yeah, but that basically we came to that after like understanding like how the scoping work with a lot of lots of sharing.
Great, thank you.
All right, I think we have time for one more question, if there's anyone else. All right, on your way out, please remember to vote on the tablets, and our next talks will begin at noon. And everyone, please give Anton a big warm of welcome.
Thanks.